All right, good morning, good Monday morning. Let me know if you can hear me here. We'll get an audio check. Considering we had so many issues last week, we had some audio issues. As always, let me know where you're watching from today. If you're Northwest Ohio, Southeast Michigan, right down the town. If you're not across the country, great. That's fine too. Write down where you're from here. And we'll get started here momentarily. Today we're going to be talking about climate and the atmosphere. Tomorrow, all about El Nino and the jet stream. And then coming up for us on Wednesday, all about Toledo weather stories. So should be a pretty fun week, I think, coming up here for us. Just a few seconds and I'll get logged in on the other computer. There's always just a little bit of a delay here. All right. Yeah, it's just a few more seconds here, and I'll be all ready to go on this end. But it does look like the audio is coming through just fine. All right, so it looks good. Got everything up and ready to go. So this is Getting Schooled. This is week number 8. Unbelievable. So it's a whole 2 months worth of this. And all of our previous broadcasts are up on our YouTube page. So look at the 13 ABC YouTube page. Also on our website, we've got a bunch of them up there as well. But this is where we're going for today. We're talking about what the term for the week is world weather. So we're kind of talking about overall weather patterns. And today we'll talk about climate. We'll talk about the atmosphere in general, how it works. And we'll also kind of break it down specifically for the United States and Toledo and how all that works out. A jet stream in El Nino tomorrow, why they're important. They drive a lot of our weather. And then on Wednesday, it's going to be kind of looking back, almost like a history lesson on weather here in Northwest Ohio on extreme weather events. So that'll be a fun one too. I've gone through, I think I've got like 10 different stories there on Toledo weather that is really kind of stands out. Next week, we'll talk about summer weather and changing seasons, and that'll be it. Week number 9 next week will be the last week for us. But today, Getting Schooled, we'll talk about, again, climate and atmosphere. So let's get right to it, and we'll talk about the very latest here. To start off with the basics, we got to go back and look at this big, delicious piece of cake. That's right. That's how we're going to start things off today, because the atmosphere is layered, kind of like this a very delicious looking cake. You've got several different layers here in the atmosphere. So if this looks tasty, maybe this will kind of stick out in your mind of how weather works, as if there's a lot of different layers in the atmosphere to it all together. So not just one, but it's the bottom layer in particular that's so important when it comes to weather altogether, because that's where all the weather essentially lives. When it comes to clouds, we've got them down here at the bottom of the screen. You can see it here. This is where the temperature gets colder the farther up you go. If you go up a mountaintop, you'll notice it gets colder the farther up you go. If we were to go out and somehow get into outer space and go up in the atmosphere, not really outer space, but still in space, we were going to go up several thousand feet or something like that, we would notice the temperature decline. And where the temperature begins to warm up, this red line here is a look at the temperature as with height. And so it's got this big funny like SZ curve, whatever you want to call it. But as you start to go up, you get up to the tropopause, and that's the point where the temperature begins to warm up again instead of cool down with height. And so that provides a very stable layer in our atmosphere altogether. So that kind of keeps all the weather clear at the bottom. Now, we talked about some of the other stuff already. We talked about the northern lights. It's all the way at the top here. We've got the meteors that are going on. So that's all above us, but we're looking at that bottom layer of the atmosphere, and that's where all of our weather is essentially being generated when it comes to winds and clouds, and all the important stuff that has a direct impact on us at home is happening right there at the bottom. So let's go ahead and take a look here at the water cycle, and usually around 3rd, 4th, 5th grade, right around that time frame. This is something that if you haven't already learned, that you would be learning during that age group or during that class level, during that grade in particular. And it's very important because, again, we're going to get to climate here real quick, but we start with the atmosphere and how everything works. You've got the very bottom layer of the atmosphere, and you get the humidity and evaporation that goes up, and that ends up leading to water vapor into the sky. So we've got evaporation and leads to condensation. Then the winds will transport it somewhere else, and eventually this cloud will rain. The rain falls to the ground. It fills up the streams, the lakes, and it runs off into the oceans. And this whole cycle just repeats over and over and over again. It's been doing it for millions and millions and millions of years, and it will just continue to do so for millions and millions and millions more years yet to come. So that water vapor, the amount of water in the atmosphere never changes. We could be in the middle of a drought. We could be in the middle of the biggest flood that we've ever had, and the amount of water on this planet doesn't change. Now, sometimes the wind will take away the moisture. Maybe the wind is pushing all that moisture to a different part of the planet, and so while we'll have evaporation, we don't get the rainfall from it. It goes somewhere else. Sometimes we get a lot of that rainfall, and other areas will dry out, but there's always a balance that's taking place around the globe. So that's very important when it comes to climate and weather patterns altogether, because again, it's a matter of this water vapor and the clouds transporting across the globe. And some of that transportation happens with the jet stream. We'll talk about that tomorrow. Some of it happens in these ocean currents. And this is a kind of a map, kind of an illustration essentially of some of the ocean currents. And you got the United States here, you got Mexico and Central America. Well, notice here you've got a lot of these little swirls happening. And one in particular that I'm drawing on the board with this big current is what we call the Gulf Stream. And this Gulf Stream is really important. This is the reason that Florida and the Carolinas is a big target for hurricanes coming up into the later part of the summer and also the fall, which is something we're going to be talking a lot more about next week. Because this stream here of water, it's pushing in really warm water where the sun's at all the time, heats this up, and this current is always moving in this direction. We're moving it right around Florida, through close to Cuba, up towards the United States, and pushes it up towards New England and eventually out towards the Northeast, and it gets all the way out towards Europe, and then it circulates back around, and then it's pushing cold air down, and that cold air ends up coming around. So it's this big loop in the middle of the ocean. Well, that transports energy, it transports warmth, it transports what could end up being some the potential and the fuel for some really heavy rainmakers, and it changes everything. This is the same reason why California doesn't get hurricanes generally, and the East Coast does. Think about it. We don't never talk about hurricanes hitting California or Oregon or Washington State, but we talk about it all the time in the Gulf of Mexico, Texas, Florida, the Carolinas, and that's because there's so much warmth that's being pushed up in these ocean currents on this part of the country. The other part of the country, out towards the West Coast, they have a cold current coming down from Alaska that's always there. So it's essentially pushing energy away from the coastline there. So it's really important to know that the amount of energy, the amount of rainfall, or rain and water on this planet, is probably a better way of putting it, is relatively constant. It doesn't really move around a whole lot. So weather is the atmospheric conditions you can expect on any given day. So the weather conditions this morning, probably when you were still asleep, we had rain and we had snow mixing in. That's not our climate. Our climate, our average weather on a day like today is 70 degrees, maybe a little cool in the morning, but 70 for the afternoon, and no snow. It typically does not happen this time of year. But again, that's not the weather that we had today. Today we had a lot of cold weather. We still have the cold weather. We'll have more frost tonight, and we'll have more frost coming up the following day. So there's a difference between what the weather is and what climate is. Climate is the average weather conditions over a long period of time. We're talking about years and decades. Weather is what's happening today, right now. That's the weather. It's what we expect to happen coming up, say, in the days ahead. So there's a big difference between the two. This is a map of the climate zones across the country, and we're in an area here. If you're watching us in Ohio or Michigan, we're in an area that typically has warm and humid summers, and we have really cold winters. It's really a kind of a typical thing that we've got. We're also in a spot here that it's called a humid continental is our climate zone. The reason we say humid is because we have quite a bit of humidity generally, and you can thank the Gulf of Mexico for that. We get a lot of moisture that moves up from the Gulf of Mexico. The Great Lakes help in some circumstances too, but the Gulf of Mexico is the big trigger. Notice where you have southerly winds that don't bring up the Gulf moisture, you get this big desert areas out towards the west. You get this zone where it can certainly heat up, but it's a totally different climate out there. You've also got some mountainous areas that will change the climate zones quite a bit too. So this is a look at the different climates that we've got across the country here. And obviously Florida's a little different. This is a tropical environment down into Florida. You got desert environments out west. We're kind of caught in between where we get those different seasons that we can definitely feel with snow in the winter and hot and humid summers is what we typically get here, not only in Ohio, but also Michigan and most of the eastern half of the country. This is a look at the northern hemisphere over the course of thousands of years and the different impacts that you have when it comes to the amount of ice in the northern part of the hemisphere. 18,000 years ago, it looked a lot different than it does today. Today, the map is over on the right part of your screen, so I'll put a check mark right here. This is today's globe that you can see. And you've got some ice that's up towards the northern part of the world, the northern hemisphere in the summertime. You've got a lot more of it in the wintertime. You've got Greenland that's essentially ice covered all the time. But you're looking at land here. This is somewhat confusing because it's showing the Arctic Ocean here as being a full ocean with no ice in it. That's not the case. This is all ice covered in here. Even during the summertime, it's essentially ice covered for the most part. There's a few breaks in it. But Greenland is also ice covered, and that's essentially it. You go back to 18,000 years ago, we were in the middle of Ice Age, and the ice cover went all the way down to here. This is basically the dividing line in northern Ohio, and then all of Canada, northern United States, parts of Alaska, and parts of Russia were all ice covered. And this is another kind of look at the United States on this lower picture where the ice cover was. Go figure, we had more ice cover according to this map than what they had in interior Alaska as these glaciers just kind of moved inland. And that's also the reason we have the Great Lakes here, because as those glaciers continue to build and retreat and melt, you get the Great Lakes to form. And that process happened over and over again as you go back thousands and thousands of years. Now, why do we get ice ages sometimes, and why do we have modern periods of warmth like we have today? Why? Well, it's essentially because the Earth is wobbly. It just kind of wobbles like a top. If you were to get a top and spin it around, you would see it wouldn't be a perfect spin. It would just kind of wobble back and forth a little bit. And this happens about every 40,000 years, 100,000 years. That's a long, long time. A very long time. So during these periods where during warm periods, Earth essentially rises, kind of like bread dough. I know a lot of us have been making that at home as of late, but you put the yeast in the bread dough ends up rising over time before you end up baking it. Well, the Earth is kind of like that. When it warms up, it kind of rises a little bit. And then over thousands of years, this changes the tilt of the Earth, and then it makes this colder. And then when the ice ends up building up, it kind of changes it. The Earth is no longer rising. It kind of contracts a little bit, and then it ends up changing the tilt of the Earth again, and we go back into a warmer period. This is a very basic way of trying to explain it, but Earth wobbles, and that wobble affects essentially the shape and the tilt of the Earth, and that affects everything else. So the Earth has been warming up. We've been in this warmer period for hundreds and hundreds of years, but it has accelerated a little bit as of late. But that warm-up isn't the same everywhere. This is a map of the United States. And this is looking at, you're looking at several decades here. You got it towards the bottom of your screen. And the whole point of this is that overall the United States is warming up quite a bit, but in certain parts of the country, it's not really at all. In fact, if you look at the southern part of the country, there are pockets here that are actually cooling compared to average. And we're slightly warmer than average here, but some of our summertime temperatures are actually cooling down, at least for the summertime highs, and the reason for that is a little extra humidity. So just like the weather is always changing, it seems like, the climate is always changing to some extent, just not as drastic over time, and trying to understand that can be a difficult thing to do, especially when we don't have as much data as we'd like to have. This is kind of a rough graph here that was put together a few years ago, showing the temperatures each decade in Toledo, and you can see these temperatures end up going down here. They come back up. 1920s, 30s, 40s, 50s was a fairly warm decade. Very cool in the 70s, and then up to about 80. And then we've had a very warm period ever since. Even this past decade, it looked like we had some cooler years about 5 years ago, but since then things have warmed back up a little bit. So temperatures have gone up and down a little bit. Overall, they're certainly up over the last 100 years. We have got about a half a degree warmer in the last 140 years. And then you look at rainfall, and that's really the big thing in Toledo, is that we're getting more humidity and we're getting a lot more rainfall, especially in the last 10 to 20 years. In fact, we're getting now about an extra 4.5 inches of rainfall over the last 140 years compared to what we used to get. That is a lot, considering that that's more than 10%, closer to about 15, almost 10 to 20%. So that's quite a bit of extra rainfall that we've gotten. Snowfall, we've gotten more snowfall. Now, this past year we didn't. Again, the weather conditions were not ideal for big snowstorms this past winter. They weren't ideal the year before. Really, the last 3 or 4 years, they haven't been ideal. But if you look at the overall trend, we've had bigger snowstorms and more snow during the winter season as we're getting more precipitation, more rainfall in general, because our climate has become a little more humid over the last 40 to 50 years compared to what it used to be. Look at the 1930s and the 1940s, we got about 25, 26 inches of snow a year. As of late, it's been closer to about 30 to 40 inches of snow a year. So there's been a big difference there depending on how far back you go. So even the snow amount has not been constant as we go through time. Some other things that affect climate, well, we talked about this like way back in week number 2, I think, but volcanoes can affect the short-term climate dramatically. So we talk about ice ages taking 40,000 to 100,000 years to get going. Well, a volcano can essentially put us into a mini ice age for only about a year, maybe 2 at the most, but it can do it just like that, very abruptly. You get the lava that goes up, you get all this smoke plume, and if that smoke plume goes high enough, I showed you the layers of the atmosphere before. That lower layer is essentially where all our weather is. But if that ash can be so strong that it goes flying right into the second layer of the atmosphere, then it spreads out across the globe. And it just kind of spreads out, spreads out, and spreads out. And enough of that ash will end up staying up there for 6 months to 2 years. And it blocks out some sunlight. It does 2 things. It produces beautiful sunrises and sunsets because of that fine ash will block just enough of it and will reflect all that light. But the other problem, it ends up blocking out some of that sunlight. Not a ton of it, but enough of it. And that sunlight is our warmth and our warm source that we have. It's like having a heater on, but we block some of the heat. It's not going to be as warm. And so because of that, it cools down the earth. And sometimes it can do it on a somewhat significant basis. And the big one was after 1815. So now we got to go back more than 200 years ago. So this is going way back, 1815, big eruption here, happens at Mount Tambora. The year after was called the year without a summer in 1816. Ash got caught in the upper part of the atmosphere for 1 to 2 years, caused an incredibly beautiful sunrises and sunsets, just like I was talking about. But unfortunately, it did a lot more damage here too when it came to all the other impacts of blocking out the sunlight. It dropped the global temperature by 1 to 3 degrees. Now that doesn't seem like a lot. But when it's the average temperature for the entire globe, that's a problem. Right now, we've been really cold compared to average. We're more than 20 degrees colder than average today compared to normal. But the western part of the country, they're way above average. So it all balances out somewhat. When the entire globe drops 1 to 3 degrees for the entire globe, it does it dramatically, it can have some big effects. And in this case, snow fell in June. We just had snowfall in May for some of you over the last couple of days, but this time around it was snow falling in June, frost in July. We've got frost now. It'll probably be the last one that we have over the next 2 days, probably the last one we'll have of the season. But in this case, there was frost in July and August, and crops died. And this was a huge problem. This wasn't, say, in Canada, although it probably was in Canada too. It was here, and it was in the Northeast. And back then, all of us essentially were farmers, and we depended upon those crops. And it had a huge impact, not only in the United States, but also in Europe, had a big, big impact from this. So that's a look at climate and the atmosphere in general. Certainly there's a lot that goes into it. Hopefully that wasn't too technical, but if you got any questions about how climate works, what kind of impact it's having, the atmosphere in general, the ocean currents we talked about, even though we're kind of getting ahead of ourselves a little bit, jet stream questions or anything else that we've talked about, I'd be glad to talk about it. But if you've talked about the water cycle, then you've actually had that in class before this pandemic happened and all of us are now out of school. You can just see how that water cycle, which seems like a pretty basic thing in a lot of these science classes in 3rd, 4th, and 5th grade, how big of a deal it is when it comes to the atmosphere and understanding how things work. You get a lake that we 2012, 1999, 1995, 1989, those were big drought years. Those were years where it just seemed like it could not rain during the summertime at all. And then yet we had periods where last summer and the summer before that, we just had tons and tons of rainfall. We just couldn't get rid of it. Last year, at this time, the farmers could not get into the field at all because it just wouldn't stop raining. It wasn't because we had more water on this planet. It had to do with the fact that the water that is on this planet just happened to be falling to the ground more often here than what it typically does. And those drought years, the opposite was happening. That rainfall that water on this planet didn't disappear. It just went somewhere else. It was being transported somewhere else, as there were big differences there in the weather patterns altogether. So, I mean, that's a look. Again, tomorrow we're going to be talking all about El Nino and the jet stream and how that has an impact on things. We'll really break that down because, especially in the wintertime, that can have a big impact on our overall patterns of what we're looking for when it comes to the winter season altogether. We also talked about just last week the polar vortex and sometimes how significant of an impact that can make on the overall picture for the winter season too. And last winter that had a lot more to do with the overall picture than, say, El Nino or La Nina, but that can certainly have a big impact too. So we'll talk about all that tomorrow. It doesn't look like we've got a whole lot in the way of questions at this point. If you've got more, if you think of more, bring them tomorrow. We'll certainly dig into it much more at this point. But so yeah, we'll give it another minute or so and see if any other questions come in here. How much is the temperature rising during the summer and colder during winter every 10 years? Well, hold on. Jennifer asking, what was the last ice age that we had? The last full ice age was roughly about 18,000 years ago. I mean, we were emerging from it about 10,000 years ago, but right around 18,000 years ago. And we had the mini ice age, which wasn't a full-on ice age, but that was several hundred years ago. We had that, but that was a notable downturn in the global temperature, kind of like that short-term scenario I showed you on the volcano where the temperatures dropped real quick over the course of about a year or two and caused all those problems. This was a little bit longer of a scale, and that was largely driven by solar activity. We lost a lot of the sunspots on the sun. We went into this deep solar minimum, and that really kind of helped to bring that on. So let's see, how much the temperature is rising during summer and colder during winter at Toledo and every 10 years. Not totally sure what you're asking here with this question. You can rephrase it and let me know. The temperature in Toledo has gone up about a half a degree in the last 140 years. The thing is, though, is that if you looked at that graph, there are a lot of these up and downs. And that was looking at not year by year, but it was looking at it by decade. So back in the 1800s, there was a warmer period then. It took a dip down in the 40s and 50s. We went back up. In the 60s and 70s, we went down sharply. It was quite cold during the 1970s. And since the 1970s, we've been rising quite a bit. Actually, we've gone up about a degree per decade since the 1970s. But again, you had these ups and downs before then. So if you kind of look at the overall trend, it was just over a half degree when I calculated it out. Precipitation, though, the amount of humidity in the air, the amount of rainfall, and the amount of snowfall that we've had has gone up significantly more. Actually, the temperatures in the summertime really haven't gone up a whole lot if you look at the afternoon highs. In fact, the afternoon high temperatures have probably dropped a little bit from what we have seen because there's more humidity, and more humidity means cooler temperatures during the day. But more humidity also means warmer temperatures overnight. So they've kind of canceled each other out. The wintertime has been a little bit warmer, but then again, we've also had more storm systems with more moisture too. So it's just the whole overall climate system has adjusted and shifted, and we see these patterns also that kind of line up when you look back at the different decades. You get 20, 30-year patterns that set up a lot of the time too. Let's see. When were the Great Lakes glaciers? Actually, it's happened several times in the past. So once you get to the middle of these ice ages, at least the most severe ones that we've had, that's when you're looking at that. So again, you're talking the last time that we had any ice around this area like that, you're going back a good 18,000 years. But it's happened several times in the past that they've been able to calculate. How many exactly? I don't know if we have a specific answer on that one. In fact, I'll go ahead and answer it. We don't have a specific number on it. Let's see. Courtney's saying, if there is a wildfire, could it make that area warm? Yes, but only for a short period of time, because wildfires are usually a short-term type of event, so they don't last all that long. But yeah, wildfire is going to add in a lot of extra heat. That's one of the reasons why we talked about wildfires and also fire nados. Again, I think this was week number 2 that we talked about this, but you get this intense heat, and that leads to a rapid rise in the air, going up really quickly. And when it goes up real quick, if you get just a little bit of spin, it stretches that spin out, and then it ends up turning into what can be a fire NATO in that case. You stretch it, spin out, and it becomes much stronger. All right. Looks like I think we're all caught up with the questions. If I missed something, I'll be here tomorrow. Come back, and again, tomorrow we'll talk about the jet stream. We'll talk about El Nino and what kind of impact that all has. So thanks for watching. We'll see you guys tomorrow.